Alright. Hello, welcome back to kottefolket game devlog. I've been a little bit sick, still am, so that's why I've been off a little bit. But anyway, this time, this might be a short session here, but I wanted to get started on the camera boundary because it's been a long time coming here. And essentially what I wanted to do is to so I guess requirements would be dynamic boundary. So what that means is essentially the boundary can change during gameplay. Boundary can change during gameplay. I also wanted to, what does a boundary mean? Boundary will not allow the camera to move past it. Camera will always be contained within the boundary, I guess you can say as well. So it will never really leave the boundary. And of course it should focus on the player or whatever is the... I guess technically you could pan the camera to if you have some kind of cutscene or something like that, but essentially, yeah, during normal gameplay, camera is focused on the player, but it will be contained within the boundary. So, which we already have that. Essentially, we have this kind of feature, but it's like I don't actually remember exactly how it works. I think it's depending on... It's kind of like it's depending on the level size. So it's like we have a boundary, but it's only like one rectangle that we're looking at. So essentially, we just need to kind of... because dynamic boundary and the way I want it to be is basically instead of just having one rectangle, you can have several rectangles. That doesn't really have anything to do with the dynamic boundary, I guess, but it's like instead of having one rectangle which represents the level, that's the boundary, we will have a list of boundaries. That's how so solution. So what I'm thinking is that we will need a list of boundary rectangles that will determine the boundary. And so we will need to check against, just like how we check against our current boundary, we need to check against all of those boundaries in order to find the correct position of the camera. So that is this is the lowest, I guess, the lowest form of the boundary. But then also, in order to kind of manipulate this boundary, this list of boundaries, what we will do is we will have a camera boundary entity type is my idea here. So essentially we will I think that we want to do a couple of things. I think that if you just have a normal level that is like just a square level that you don't really need to define a special boundary, then we could just do the default where the actual level size is the boundary as well. So that would always be so basically level like the map should always be a default boundary. And so you don't always have to define the boundary through the entities. So when a level loads, create boundary rectangles for each camera boundary entity. Okay, very simple. However, I think also that the camera boundary should have an enabled property. And so we will filter out here when a level loads for all camera boundary entities that are enabled, creates a little bit of pseudocode here, create a boundary rectangle. Okay, because if you have a secret, then that will have a boundary. I mean, there might be a way better way to do this. This is just a solution that I came up with to kind of fix this issue here, and it seems to be fine. But whenever you have like a secret, that's when I think it can become a little bit tricky as well. Also, oh yeah, I didn't think about this, but we actually need to change the algorithm for checking against collisions, because the boundaries can actually overlap. Or well, they can overlap, and they can essentially want to treat all the boundaries as one single polygon and check collision against that. So yeah. So maybe this isn't the best way of doing it. I'm not sure. I mean, if they are all just rectangles, then it's a simpler shape, I guess. It's not strictly like a polygon, but I was just thinking, man, because like if you only have one rectangle, the camera is pretty easy to limit to that rectangle. But now we have a bunch of rectangles, and you're supposed to be able to kind of travel through them as well. I mean, or we can also do this. We can also say, okay, which rectangle is currently active? And then determine somehow that is the current boundary, because yeah. Or even like the current camera settings, sort of. I'm just thinking back how Hollow Knight does it. Like you have a T shape, like an upside down T shape. Like this over here. This thing here. This is an upside down T shape. So when you enter over here, the camera boundary is basically, you know, this corridor here. But once you enter the mid part, well, at least in in Hollow Knight, it goes into this other kind of camera mode, because you can see the camera kind of, when you reach here, the camera kind of moves up, I think. It moves up a little bit so that you can you kind of unlock the verticalness here. Excuse me. So that's why I'm thinking that, okay, so maybe it's like when you're in these corridors here, there's a certain camera mode there which determines the boundary and everything. But then when you reach a certain point over here, the camera goes into the mode of going into this part over here. I'm just not certain exactly how to transition there. I mean, it could just be that we have a rectangle here that determines the boundary over here, or the camera settings here, and then another rectangle here, and then one over here. And so when the player actually collides or goes into this region, the camera kind of goes, like, locks into here. But then we don't want the camera to kind of I mean, yeah, I don't think we want the camera to kind of be locked here, because what if you want to go the other way? What if you want to go this way? Then you don't want this to be... Actually, kind of want to start up Hollow Knight to see how they do it, because... Yeah. Because when you're up here, you don't want the camera to kind of move past these walls either. I mean, there might be... You could have a rectangle maybe here then. Like a rectangle here, and a one here, and a one up here. No, because then you still have this... But then you can have a setting that says that, well, horizontal is like unlocked here, so there's no boundary at horizontal. Yeah, you could have that. And up here you have like so here is like horizontal and vertical is unlocked, sort of. And then up here, horizontal is locked. Well, I guess both are locked. But then you can't go past down here. Then it's gonna block down here. Maybe we just say that it's blocked at the top and not at the bottom then. I mean, either I'm overcomplicating this, or I'm finding the actual solution. I don't actually know. I'm gonna grab a cup of coffee. I'll be right back. All right. because it's like, even if I build all this, what if it doesn't work properly? Then I've spent a lot of time doing all that. Like, I don't think the camera system is like super easy. I tried to like search for resources for like you know, standard practices for these kind of things, but I don't know, I find it pretty hard to find resources on this topic. I'm just trying to imagine like all the different issues that could arise, and the kind of behavior that I actually want. So this is just a simple, you know, having it just a simple. This isn't even like dynamic boundary. This is just having a simple level layout like this, and then having the camera going to different modes. It's just that you wanna be able to have the camera. Well, actually, yeah. So you could have a rectangle over here. I mean, you could even have like one rectangle here, but then you have one here that kind of overrides some of the settings. Now that's getting too complicated. I think we should always have like only one active at a time, probably. So we'll have one here that's just a normal boundary, except it's unlocked to the right. Yeah. And then over here we have a normal rectangle, but it's unlocked to the left. And then in the middle we'll have one that goes like this. It's unlocked to the left, right, and top, but not the bottom. And then here we have another rectangle which is unlocked at the bottom only. And then comes the issue. Like, let's say we have a secret over here that kind of unlocks like a long corridor or something to some secret over here in this space here. Now we need to be able to change somehow the settings or the layout of the cameras. Well, okay, so my first thought of this was that, okay, well, what if we also define camera set like this entity beforehand, and some are activated and some are not. So you would have maybe a rectangle, maybe I mean, yeah, you could have a rectangle here that is unlocked to the left, and then this part over here is its own thing, and then those get activated. But also, the thing that I also want is like, what if you can open up this and up to another room over here? Well, then I want to be able to either change this rectangle to unlock the left side, or have two rectangles at the same time where one is active and one is not, and they have different settings depending on what you want at a certain time. And when you open this wall, it will deactivate the first rectangle and then activate the other rectangle to open up like this. Like, maybe this is another rectangle that is actually activated then, and then this is deactivated. Because then what's the effect of that would be that when you open up, so first when you go up here, the camera is bounded to this part. But when you open up this wall, it will now kind of unlock, so all of this will be available. So then the camera will kind of, oh shit, I had the players over here, so now the camera, which was over like this, will now shift over to something like this. So that will be the effect of actually opening up this wall. The camera will pan over because now you can see through there. So I think that could be possible to do. It's just I'm a little bit scared of getting into the situation where I spend a lot of time implementing this and then it just doesn't work for some reason. But I think we should try it because, yeah. So the first thing that we need to do, I mean, we could start simple, I guess. We could do a camera entity type. We could just, yeah, create these entities over here and then have different settings on them. And depending on the settings, we would have then different things happening. So I think what I want to do is I want to create a new scene that is like a boundary. And I'm just gonna create this thing here. It's gonna be very simple. I want to be able to jump up here as well, because what I want to test is if I have a setting that it's unlocked to the left, for example, and unlocked to the right, bottom and top. I want to be able to test that all that works. Yeah, I'll just do that there. Okay, so that is the tile map. And this is the start. And now we can go in here. So the camera now is like it's locked onto the level itself, which I feel should always be like the default. But what we want to have now, I think I want to do this in code first. Or maybe it's easier to do it here, I guess, maybe. I don't know. Let's just do, we'll make a new entity type, which is a camera camera boundary or camera, because really it's like camera settings for this region. So I'm gonna call this settings. Okay. And we don't really have but we do want to have properties, and this will be enabled, and default should be that it is enabled. Okay, and then we'll have so I'm gonna say locked left. Could also make it into an object, like locked is an object. I never actually used this. Locked on left, which is a boolean. which I'm gonna enable all those to true actually. No, actually let's do right mathematical and then top. Left, bottom. Okay, so those are the properties that I can see now that we should have. Yeah, so yeah, I'm not sure what else we would need, but we might want to add more in the future, but this is where we should start now. Okay, so now we have that, and then we go over to our scene here, and we can actually add this in here, and we can make it stretch over there. We can hide it so it's not covering the things. Okay, so there's our camera settings. Now, what we can do is we can go in here and we can enable it or disable it. We can change the settings. So let's try and unlock the right side. Okay, so now we just need to implement this in in the code as well. So yeah, so I'm not sure about this plan anymore, but let's go to I believe we have like entity. No, not this one. Is it scene? Yeah, here we go. So here's the entity types. I guess I'll put it here. Camera settings. Okay, so we have enabled, we have locked, which is a struct, and which, left, no, right, top, left, and okay. Oh, okay. I have another thing going on which changed the Zig version, so I have to change this back here. There we go. All right. Okay. I think we add it maybe here. Actually, then this would be here. Oops. All right. And we'll just add it. I'm just gonna add it here. Okay. So here's where we kind of load in the entity. And of course, we need to create the thing. We need a camera settings component. Since we're using ECS. All right, so camera settings component. Now, I mean, essentially, this would just have the same properties, I guess. I'm just gonna do that. So we'll have entity camera settings, import. Actually, you know what? This should probably be here. Yeah. Alright, so that is the component. Now we have that in our convenience file here. Okay, so now we can add camera settings where properties equals properties. And there we go. That's basically it. Well, okay, we also need the rectangle. Yeah. There we go. Excuse me. Okay. I mean, okay. We could have made, we could have done the same thing here where we just add the properties as a component or whatever. And then we also have entity ID. I'm not sure if we need, yeah, we do. Actually, we do need this because it's supposed to be able to be deactivated and activated based on entity ID. That was not the thing. Okay, there we go. Okay, so now we have the entity registered in the memory here, in our registry container. So now we can actually query that in the game, and we can do we actually have a camera system? I'm not sure if we do. We just have a bunch of camera functions. We have this update camera, which is just called right. Well, this is a special case. This is where it's called, right? So this essentially is the camera system right here. So here's the old way of doing it. We have this boundary function that just calculates the boundary based on the level. So we just get the level boundary and then use that. Ooh, excuse me. Which should be the way we're doing it if we don't have any things there. But I think this boundary should now be a little bit more. It should not just be an AABB actually. It should be an actual camera boundary construct actually. So camera boundary. And I mean, yeah, so this should be, they should have the same thing here where you have this locked thing. And now we can actually use this instead. Over at scene. And then camera settings. Well, you just have the properties. Yeah, so now we can easily just set that. So, camera boundary. We have the locks. We should also have a rectangle. So there we go. And let's see. So the camera boundary should return a camera boundary now instead. Which I should really expose somewhere else. It should probably be in lib or something. Yeah, sure. Let's add it here. Actually, oops. Let's do this instead. Scene. There we go. Now where are we? Here. All right. So you will be camera boundary. And if we just want to do this one, I guess we can have like init locked. Yeah, I will just add this default to true. Okay. All right. Right, so now we have to actually do this. That's fine. Oops. Okay, let's see if this works. I just need to build the game first. So yeah, it still, you know, works like it did before. Checking the left side as well. Yeah, cool. Right. So I mean, yeah, we get a boundary now. We can, and now we have new things on here. So it's this function's responsibility to figure it out now if we have like locked stuff or not. And here we're doing like something with the climb. I'm gonna leave that for now. I'll add a to do here just so we don't forget this. Figure out if we need to fix this with the camera boundaries. Alright, so the target is like, it's gonna be the player, I think. Essentially. It's just gonna be the player, yeah. We are doing stuff here. I'm not sure if we even use this here. Oh, I see, we have a little bit of offset as well. I didn't actually think about this here. I mean, it doesn't matter. The target is just where the camera wants to focus on, but it's not necessarily the actual position of the camera. So it could be the player. If the player stands near the boundary wall, then of course the camera should be locked to the wall. Alright, and then we're doing some shenanigans here where we're calculating if we should, if it's like, if the distance is low enough, then we just snap to the target. I was just thinking, well, that overrides the, that could override the boundary stuff, but actually we're checking boundary down here, or we're doing the actual boundary down here. So this is where we calculate, okay, where the camera position wants to go, and then we lock it to the boundary here. But we should only lock it if, wait, no, that's the target. No, wait, yeah. Target is the actual position, yeah. Because this is a raylib camera, so raylib camera.target means where it should actually be shown. But I'm just thinking, like, we only check, no, we check top left, right, this is a vector operation, right? So we're checking two things at once. We're checking top left and then also top bottom right. However, this is not how we want to do it anymore. Then this is the way we want to do it if we are locked. But I think it's better if we just say I mean, let's, for example, let's say we have X. No, wait. I'm just gonna do this to make this easy here for now. So this one is like camera position. Wait, so this one is right. So we need to do the X to get X and Y to get Y. So there we go. There's our initial things. If boundary locked to the right, then X should be min boundary rect right, and X, if it's locked to the left, then X should be max, boundary left. If we're locked up, wait, no, top, bottom. See? Up, down, left, right, top, bottom, like these are, well, these are very CSS, like web development terms here. I'm not sure what the usual thing is called in like game development, if I'm using like the wrong terminology here. I don't know. Okay. Oh, and this should be Y, of course. All right, so now we say that, well, we can simply say, we can actually just do this as well. Okay, so I think now we have the ability to kind of unlock different parts of the camera. So let's test this now. Okay, let's just test this first with a normal thing. Alright, it seems to work. Well, except it doesn't. Okay, interesting. So it seems to be... Okay, so I might have done something wrong here. Just maybe. So this should all be true. Okay, I might have mixed up these. Let's see, right should be positive, left negative, top is negative, right. So these should be the other way around here. I'm gonna do this just to have min and max be at the same place. Symmetric, that's the word. Okay. Okay, now we go up here. Okay, cool. Okay. And I mean, a simple test of this would be to say, well, hey, let's say top is not locked. Whoops. Yo, Elsos, what's up? What's up? Welcome to the stream. How's it going? Okay, I need to actually go in here and test this here. Okay, there we go. Top is unlocked, but the other ones are locked. Okay, cool. I'm gonna assume that the other ones actually work. I mean, we could just unlock everything, I guess. And try it one more time. And that should just not do anything with the boundary. Okay, I did the same thing again. Let me go up back here. Okay, there we go. It's unlocked now. Cool. Okay, so that's one of the steps. Now, gonna remove that. And so okay, so we have the basic things there. Now what we can do now is that we can go back to the camera. So the boundary, how we get the current boundary, should then depend on if we are... So how I'm seeing this here is that get camera boundary. So based on player position, get the boundary, get the closest, or get the boundary. Get a camera boundary entity that collides or that intersects or contains or intersects. I'm not sure actually. It should be intersects, I think. No, I think the center, the boundary entity containing the player's center point. Yeah. If there is no such entity, use default level boundary, and this is the actual level boundary here. So I'm gonna actually move this out into like get camera default boundary, which is gonna be this part there. All right. But here we want to get the boundary, and so first we need the player position. So I believe we have the player, or is it in? It's in here. Do you even use? No, you just need the registry really. Okay, well actually let's just do this. We get the player, we get the thing. Well actually we don't need to do this because we have game.player. Alright. So player position. Alright. So player position. Now we want to go through every camera boundary. Now this is a very simple collision check. So I think we could just brute force it, because we should probably have like maximum of like, I don't know, 5 or 10 camera boundaries that are actually enabled as well. So let's just get the camera boundary view here. So the view will give you actually this will be camera game settings, not camera settings. So this will give you all the entities that have the camera settings component, and then we can get an iterator. Actually, we don't really need an iterator. We can just do data, I think, or is it raw or whatever. Actually, it might be an iterator. Right. So we get this. We get the entity. Yeah. I'm not sure why it doesn't understand what it is. Okay. And then we get the camera settings. Actually, this is a basic view. This is a basic view. A basic view just has one. It just has one component type. So this is a lot easier because now we can actually just do data instead, and we can. Actually, do we care about this entity? I don't think so. We can just get the camera settings directly, actually. Problem is, the LSP, I don't think it understands what type this is. So, but okay, anyway. It's not really an issue for the compiler, but it's an issue for the LSP. So, hello Solar Corium, what's up, what's up, what's up? Aren't you usually on YouTube? Recognize you have a different name on there. Let's see. Right, so properties enabled. So if this is not enabled, we will skip it. But if it's enabled now, we should wait. Oh yeah, that's right. It also has a. Oh wait. We do need the entity. We do need the entity because I forgot that we stored a rectangle in another component, so we actually need to get the entity, and then we get the thing, and we get the thing. Actually, we could just store this as a boundary, to be honest. Like, instead of adding this and then this, we could actually just add a camera boundary. I just need to add this thing. Hello, Minister of Defense. Welcome. Is this your first game or have you made any before? I mean, yeah, I haven't released any game. I haven't done any like serious game or anything like that. So this is like this is the first game that I've come this far, I would say. Are you a game developer as well, or just interested in in games? Always Twitch, but I got shadow banned. Oh, I use Mulvad VPN, and my connection was flagged as suspicious. Haven't been able to get rid of it. What? Oh, sorry to hear that. That's too bad. I thought the VPN stuff was good to use, but yeah. I mean, I don't really have it myself, but oops, shouldn't have said that. No, but yeah. Let's see. What am I doing? I want an init function. Actually, we can use init here. We don't. I mean, this is really unnecessary now. So, which is really the power of these. Oops. Implicit. Yeah, implicit declaration. Whatever it's called. But at the moment I'm spiritually recovering for this slump open source project I looked at for a bit. Oh shoot. Okay. Do you mean Runic? I'm a normal dev, but I'm working on a game on Zing in my spare time. Okay, cool. This is my first time making game. Nice. I mean, we're kind of in the same boat. I've been trying to make games for a very long time, but I just, I never had the energy or motivation to actually finishing anything. Like, I just started up a project, got to a certain point, got stuck on something, lost motivation, lost energy, and got another idea. Oh, let's make this game instead, or this game. I think that it's like you don't realize how much work it is to actually make a game. So you just want it to be done, and so you can play it, the thing that you're thinking about. And what you really have to do is like actually try to find a way to continue to work on something for a very long time until it's done. Unfortunately. Yeah. But yeah. But of course, every time I made a project, of course I learned more things as well. So it's not really, it wasn't a waste of time or anything like that either. But okay, I think we're back here now. So camera settings is going to be view.get entity. So now that should be properly typed. No? Okay. It's a Rust project called FineLore. Okay. Or FineLore. Supposed to be an accounting system, but it's so unspeakably far from one. There are just no words to describe how bad it is. Interesting. A Rust project as well. Why is everything Rust? How is AI so good at Rust as well? Like, Bun was rewritten in Rust very quickly. Right. Yes. Okay. So we have this thing. Well, actually, now we don't actually need to get the entity because we have everything we need in. Actually, this is not camera settings. This is now camera boundary. So this would be the boundary. Whoops. However, it does not have if it's enabled or not. Maybe that should be baked in here. Sure, let's add this for convenience. And we'll just add this here. I mean, whatever, it's such a small thing. Let's see, properties locked, properties enabled. Alright. And then you enabled should be true. It doesn't actually matter at that point. Alright. Now, so if it's enabled, now we can simply go rectangle and I forgot what the function was called. Contains point. Player position. So if we don't contain the point, we skip this one. Otherwise we have found our match. There's only gonna be one match here. Yeah, because I'm a Rust developer, so obviously Windows has couple of, yeah, of course. AI was not cooking on this, not with Bun either, to be honest. Okay. Oh, have you looked at the actual Bun source code, or is it open source as well? Or maybe, I mean, is the source code available? Interesting. So what's your biggest complaint with the AI for that on those projects? That's gonna be interesting to see. I feel like if you just let AI roam free without any directions or anything, there's like a very small chance, it feels like, that you're actually gonna get what you want. But with a little bit of direction, I feel like it can get the job done pretty well. It's just that you easily fall into the trap of, hey, AI can just fix all my problems for me. I don't need to actually look at the code or anything. I can just let the AI do everything. But that's yeah, that doesn't work. Bun source code is open source, but it's like 1 million lines long. Okay. Okay, so now we have found the boundary, so we can essentially just return here. Actually, oh yeah, so yeah. So we can, I mean, yeah, we can essentially just return this boundary. But we could get out here, so if we didn't find any matching boundaries, we will return the default boundary. And there we go. So now we should actually, this is like hold every frame, which I guess is okay. It's not really that much happening in here. Okay. Let's build. And we'll test this, if this actually works now. If it's like, if the entity takes like priority now for the thing. Okay, so we seem to be locked on bottom left and top. And right as well. I thought I put this to be unlocked. So the right should be unlocked. Okay. And it is enabled. So I'm gonna guess that what's happening is that it didn't match anything here. So if it's not enabled, we skip, right? If we don't contain this point, we continue. Is there something wrong with the rectangle? Like, is it world coordinates or is it... Actually, the position should be like 0, 0 because it's covering the level. I'm just gonna double check how this is done here. So we got entity position. That should be world position and then the scale. Yeah, this should be world coordinates. Is there something weird with contains point? Top left. Top left is negative. So this means that this is further along. Bottom right is positive. Yeah. Like, I'm not sure if I actually ever used this function, so. I've seen parts of it. What their strategy is to just have it basically translate the Zig to Rust file by file. By this translation book, it's set out, but not everything translates perfectly, so it has to make this really odd helper functions to do things. The code will be memory safe, but I fear there will be some very strange bugs. Another thing that concerns me is also how the Rust and standard library and the Tokyo async... am I saying that right? Tokyo... Tok.io async library use the same names for structs that implement different things. I mean, yeah. They did run the tests and stuff. I mean, they have a lot of tests, I guess. They passed a lot of them, but yeah, the problem there would be maybe, let's say, there's some tests that don't go through, which is very important, and in order to fix, they have to go in and fix a lot of stuff or something like that. I mean, either way, I think someone actually needs to go over the code to make sure it actually works or does what it's supposed to do. I don't know. It feels weird. It's like, yeah, if you have if you're doing like it's like a new paradigm. It's like test-driven development, but AI is coding, so you don't actually need to look at the code because you know it works because of the tests. So, but yeah, I haven't looked too closely, but I recall it being quite a bit of unsafe blocks as well, so my memory save point might have been... Right. I mean, okay, I guess I understand what you're saying. Like, Zig does things the Zig way, and then if you try to translate that directly into Rust, you have to do a bunch of unsafe blocks instead of doing it the Rust way. So yeah, I mean, why even change the language then? I don't know. Like, yeah, why even do that like that way? Why not do it the Rust way instead? But okay. I mean, I guess as long as it works and as long as it doesn't lose like a lot of points on like the benchmark or something like that. I don't know. But yeah, it does feel like a very bad translation in that case. Essentially, like, yeah, I don't know. So why does this not work? Why does it not work? Let us... I'm pretty sure this entity thing is correct. This rectangle here. They had to change because they were having issues. Wanted to merge changes to Zig, but Zig doesn't take AI contributions, so they moved to Rust. Yeah, that's the thing. I'm having so much trouble in actually figuring out what they wanted, like what was the issue. Like, does anyone have any like article or something, like a link to the to that? Because I've been trying to Google like bun Zig issues or whatever, but I haven't found anything. Maybe there's new stuff now, but the Zig guy, Andrew Kelly, was very anti-AI, and Bun is owned by Anthropic. Whoa, okay. It works at such a low bar as well as I'm seeing more and more. Okay, well, I mean, yes. It's a low bar. That's why I added the benchmark stuff as well. But it's also like, okay, can you really trust that AI could figure out with that code base how to add new features? Because if it's true what you said, that they took it file by file, it's like, okay, but how do you now work with that code base, like as a whole, in Rust? It feels very strange. And I'm having trouble figuring this out here. Should we just log this out? I just want to make sure that this is correct. I'm pretty sure it's correct, but so camera settings, correct. I'm pretty sure we have a format function for that. And build. Yo, Penguin, what's up? Well, I can search. So bun Zig issues. Why bun leaving Zig is great for Zig. Like, I only find these weird other things. My thoughts on bun's Rust rewrite. Bun is being ported from Zig to Rust, page 4. Okay, this actually talks about the issues here. Memory leaks. Okay, I'm just gonna see if we get this camera settings. What? Oh, we didn't even get the thing. Wait, could not parse properties of entity, camera settings, unexpected token, enabled. Oh, wait. Oh, sorry, you're not seeing anything here. Okay, I think I might have messed something up here. Let's go back here. So this is a bool. However, if we actually want something to be a property, we need this thing here, because it's like translating from this JSON format. So I actually need this thing here. Right, I forgot about that. Do I actually have an object? No. Shit. I need to extend my system here actually. Okay, sure. So property object how is this formatted? I don't remember. No. It's in scenes, and then we're gonna do boundary scene, and we're gonna have locked. So locked is a thing that has an ID, and then we have property, which is an object. Okay, and then the object is just a struct, or just an object here actually. Okay, yeah, so that's recursive. Cool. So this would be the properties type. No, wait. No, this is just a type. Yeah. And this is properties. And the object is actually just the properties. So that was easy. Value is... what is this? How long have you been using Zig? About 2 years now, I think. Like, I started out when it was 0.13. Right, so this gets the actual... this gets, like, the properties. And then get item. This should be like the field. This should be the key. So this would be a... I mean, it could be a string. It could also be a comp time field enum of properties, which then gives us it gives us properties. Field info key. Type. So that should be a property, and then dot value. Because I think all the properties have a value then, no? Yes, so it's like a convention here. So we can use that fact to just get the type here, get value. And then this value will simply be properties then. And here we would get actually now I was thinking, like, because the array is a bit different, because this is like defined as a property type, which you can just say like array of dot boolean instead of saying property array of property boolean. So I made this kind of convenience thing here where it like converts this into a property, which we could technically do the same with object. The problem is recursive, like this only works like one level down or whatever. Whatever. Let's just do it like this. Fine. So, okay. But this gives you the value of this item. Instead of doing this, we would just say, well, now we need to say at field. Whoops. And then tag name of key. And then dot get, because that will now be a property that we get the value out of. Yes. Okay. Right. And then these properties well, that's not correct. Wait. No. Okay. So this is actually okay, so if you can see, so locked was actually, I need to change the type of that, so that's, but this one is now a property boolean, so I need to say get to actually get the boolean out. So there we go. And the locked, that is a different thing, because that's gonna be recursive. So I would like to just say it's an object which translates this into the format. But really, so the original idea was to do like, well, this is a struct, and we have like right is a property boolean and so on. Oh, let's just do it like this, because no. Actually it's gonna be like this, sorry. There we go. Alright. The problem here though is that if we say .get, we actually don't get like the actual thing we want. We get like a struct that has a bunch of properties on them. So we actually want to call get on all the fields instead. Okay. Because this one, well, I guess it just gets the items, so it's kind of the same thing here. It gets the array of items. What if but those are, yeah, then we get the actual property. I'm not sure if we actually use this. Like, we don't map the items into their equivalent value. So that kind of breaks the pattern here a little bit, because .get should get like the unwrapped type, so to speak, I'm gonna say. But here we don't actually, but I don't think we use this anywhere except for here. Like, what if we do this and this? I mean, we have a bunch of other issues right now. I'm just gonna do that. Oh, I see. So now we can't. Okay, so it was actually used over here. And now you can see we actually call get here. But that's what I think. The problem is with map, like, you can't easily use, like, do a map operation in Zig without passing an allocator. So unless we have like an iterator, if you get an iterator, then it would work. The problem, okay, if we just want to focus on the actual problem here right now, is that the object, when you call .get, we actually don't, we get like a bunch of properties. We don't get the raw object. But in the case of an object, we can actually easily, I think, automatically convert it. So what if we say .get actually doesn't return properties, but it returns the translated properties, which would be well, first we need to construct the type. Also, does this really work here? Parsing a property, we get the property, we parse it as a property which has the property type. So actually we need to add objects here as well. I don't remember exactly why we need a deferred here. I'm gonna follow the same pattern as the array. Although here we don't really want a property type. We just want a type. Any type. Actually, I guess it is a property type. No, this doesn't work. Yeah, because when we want to initialize this, it's like we need a bunch of properties. We need like an any type here. Or a type. So this, I mean, all this is essentially gonna be comp time stuff. Yeah, that seems to work. What the hell am I looking for? Property object. No, so not instead of doing property object, we're gonna do property dot object and call this as a function and then provide the struct like this. Yeah. Okay, so what I wanted to do was to compile this and see if we get any errors. Okay. No. Cool. Now, okay, so let's see. So, okay, so what I want to do here is to add a function that gives us the properties like unwrapped. So first we need to construct the type where it's unwrapped, which essentially just goes through. Okay, let's create that type here. So I guess the value would be that type as well. So we could do that like this. So essentially this would be a struct. And here are, so the names will be the property names. The types would be property types. And then the attributes well, let's just do that as well. So that is that. Now we need to create these things. So I believe we could get the names like this. Property names. Right, that's our names. Okay. The types will be types pointer to a constant, right? So this will be a list of types, which I'm going to say is m. Well, undefined, right? Undefined, that's the way to do it. So it's undefined. Okay. And we go through field info of properties. No. Fields of properties. Okay. So we get the fields out. Am I missing a parentheses or something? What's happening here? Oh, I see. This is not a function, right? So this needs to happen comp time. Like this. There we go. Oh. I see. Okay. Or wait, actually, I think if we mark this inline, maybe it works. No, it doesn't. Okay, so it needs to be comp time here. So for fields, property types, And we also need an index, I believe. Property types is going to be equal field.type. Okay. And then we also have field attributes, which I'm not sure exactly what it is. I'm gonna have to look this up here. So it's a type struct field attribute. Okay. Comp time is false. Yeah, I think they should all be null, to be honest. Like, they should all be default. The comp time is weird. Like, we should never provide a comp time attributed field here. So I'll just do that. So these are all the defaults. So actually, we can just take the default values by doing that. So that's fine. Can I store comp time on the type at runtime? Right, so these are comp time stuff. So wait, that doesn't work. Do I need to put const here? No? I'm pretty sure comp time or should work. Or is it more comp time? No? Or do I put comp time here? I'm confused. Like, cannot... Okay, we could do it up here as well. Like, we could put them here as well. Because this is in a function context. It's also comp time, so it's not accessible from here. Right, I'll put it here. Like that. Okay, expected, yeah. Okay, there we go. Okay, so we constructed the type now, which is now like the unwrapped. Well, actually it's not unwrapped yet, because we simply take the type of the field, which is a property type. So we can extract the actual type by using our convention, the value declaration from the type to get the actual unwrapped type. So there we go. Okay, so now we've constructed this is kind of constructing the unwrapped object, and you should actually return the value, which you're not doing right now. So this should result in a compiler error right now, I think, because this is the wrong type that we return. No? What the hell? Are we not running this code? Maybe we're not even running the code. I mean, it's over here. Yeah, we should be, because we call this. Yeah? So we should be having this big run. I'm confused. Because this takes the value out, so it's not the same struct. Is it because... it might be because we're not calling get. Right, we're not calling get. So we should call get here. Okay, let's take this back here. Now we should get a... I mean, we should at least get one here, yeah. Right. And now, if we type dot value, we should get another. We should get another error. Right. So now we get this error. Expected value found this other thing. Okay. Cool. So now we need to convert this into this. We have the type, the result type that we want, but we don't actually use it. So what's nice here is that we can simply say result is a value, and we can just well, I guess we could start out with undefined, and then we can do an inline for fields. Well, actually we just need the field names, a value, and this is the name. In the end we should return the results. Okay. And then the field of result with the name is equal to field of property object name, and then dot get. So we're translating it. Yeah, and you need to be comp time. So is it, do I add comp time here? I forget how we do it. Or is it comp time here? I think that's it. Okay, but you actually now complain because you require locks, but you get value. Now they do have the same struct, like they have the same structure, but they're different types anyway, because this is, yeah. I mean, the best way to that we would want to do this is actually gonna be instead of passing a struct like this, what I wanted to have was to say that this is gonna be camera boundary locks. So we like automatically translate this into a property object. So let's see if we can do that, because that will allow us to use this to be like the actual thing that you get out at the end as well. Let's see. Yeah, so this would get us this thing, which gives us properties. So now properties is not gonna be guaranteed to be actual properties. Actually, we need to like convert each thing into a property object or a property type. And I don't think we have that reverse thing yet. Like we have these entity exit, for example, which actually is not it's not translated here. No, I don't think we have that automatic translation. So we need to create that then. Okay. I guess we can put it. I mean, it has to do with the object right now only. So let's do. So we'll have a function zig to property zig gives us a I mean, do we want a property type or a yeah, I mean a property type actually gives us all information we want, and it's more more defined. So we simply want to switch on type info of this if it's a pointer and so I mean, okay, let's actually do this. If zig is equal to a string, we return a string. If it's equal to this, we return a float. Because this essentially, you can see the value here is what corresponds to the thing we want. So we have bool, we have string, float, entity reference, array, and object. So that's what we have. If zig is a bool, we return a boolean. If zig is a entity reference, we return entity reference. If zig is, what was it now, an array? Okay, then we actually need to check this with type info of zig. Oops. And we wanna check if this is a pointer. Excuse me. Hello SQF, what's up? And I think we wanna check, it's supposed to be a slice. So it's like size has to be a slice. If it's not equal to slice, there's going to be a compile error. Invalid pointer size. Otherwise, we will return array of child. However, no, that doesn't work. We need to array and then also convert the child, right? So we need to convert you with zig to property recursively, actually. There we go. No, child. Okay, so that's the array. We can also have a struct. And and then we simply return an object and this is actually gonna recursively call this function. So so we simply put this in here. No, because then we don't have. Then it's gonna be infinite, though. Right, I need to refill my water here. Be right back. All right. Wait, or will it be infinite actually? This is called from here. It's not called directly from here, but it's like there needs to be a path from where property object will be able to call this function to turn it into a property object. Right. It almost makes me feel like we need multiple things. We need like both. The target type. We need both. Well, we really only need the target type, to be honest. Man, it's not jumping straight at me, this solution here. Unfortunately. Because this breaks the pattern here. Like this works recursively, this does not. And if we do this recursively, we lose the original type information also. Which doesn't really matter in the case of everything else, but for objects it does matter. Because of how Zig does not allow structs that have similar shapes. Like TypeScript, for example. TypeScript allows two objects that have different types, but the types are like have the same structure. Like they have it's an object that has the same fields or something like that. It allows you to kind of equal the other into the other, and you know, they can be used interchangeably. In Zig, it's not like that because reasons, I guess. So even if you have two structs that have the exact same structure, that you cannot easily turn one into the other. You can do like a cast. But it also requires like every attribute and everything of the struct as well. It's not only the fields, it's also like other things that need to be the same. Because I was thinking like this loses the original type. What if we like embed the original type as well into the thing? So it's like you could provide the thing here and then also a resulting type as well. God damn it. Maybe in case of objects, we can say like, okay, convert this to this type or something like that. Yeah, let's do that instead, because then I think we can actually if we say then, for example, that this is properties, so the thing we get in here has to be what we have here now, yes. And I get it would. The problem is we are also violating the interface now if we want to add another variable here. Unless we change it for everything. Yeah, I mean, I guess we could do that as well. So this is the idea. Instead of using value, we have this resulting type T. And then we don't actually do all this. And the value is actually going to be properties. Because we don't know really what the value would be, because it depends on what you put in for get. But the default, I guess, would be the properties. All right. And then, yeah, so then every time we call get now, we have to provide the type that we want out. Or we could also introduce another pattern. We could introduce another function in the interface, which is gonna be like get into or something like that, or to t. And really it's only applicable to objects. Okay. Yeah, fine. And then we don't really need this. I'm just gonna do that. And then we have the camera settings. So now instead of actually, well, you know what? Yeah, you know what we could do? We can say like object, and then actually we can do this here. Like if let's say this is an any type, and if type of properties is equal to a property type, then we can simply return wait, no, that doesn't work. It's not a property type. No, it's a type that needs to adhere to the thing. Yeah. I was thinking like if we could like either provide a struct of properties or a struct of normal like sig types. And then kind of, I mean, you could still do that, I guess. You could kind of look at if the field names are properties, then we don't need to change anything. If they are not properties, then we need to convert it into that. I mean, yeah, you could do that. You could say like, let's say we get the first field, field info. Wait, get the fields of properties 0. So it has to have at least one. And then if the type, you could do, I'm gonna do a very naive approach here. If we don't have a if we have a value declaration, we can assume it's a property. Is type property? Whoops. Why does... Okay, so if it's if the type is a property, we will just return the thing. Otherwise, we need to convert it. But then, since it should be a struct, we simply do this, because that should do that anyway. Okay, so what that gives us is a way wait, has declaration. No, it's supposed to be a type. What? Wait. What's happening? Expect to struct in a unit opaque found bool. Oh. Wait. No, but wait. We give a type of the field. Oh, I see. So that means it should be false. So it has to be struct enum. Well, it has to be struct. Wait, no, wait. Hang on. Yeah, it has to be struct. It has to be property. Right. Right. So, if type info of t is not equal to struct return false. Okay. There we go. So, where was that? Is type property object. Right, so now we can pass either like a normal struct, which is gonna be turned into a property struct, or we can just put in a proper struct if we want. Okay, cool. So but here we actually need to take care of converting the type here. So we essentially need to do this part, except the other way around. So I'm gonna copy this and property names. So this will be from Zig type. Same thing here. Now we don't have value. What we have is, well, the type should be zig to property, I think. Yeah. So that's the recursive part. And then now that should have the converted type there. And this one is not even used, so we don't really care Well, actually, I mean, we could just do s.fields here. We don't need to do this. There we go. And then we even get better things there. Okay. So arrays, structs, other things we don't have right now. So I'm gonna say if we get anything else, we get a compiler error saying invalid type to convert to property. Oh, right. So this needs to be property of that. There we go. I mean, I enjoy doing these abstract weird things. I don't know. Okay, so great. So what does this give us? This gives us the ability to, let's remove this. Do this. Say this is a property, that's an object. I mean, it really gives us the ability to not store these as these structs, because we can simply say, hey, this needs to be converted into, you know, an object. So we can simply say this is like zig to struct or zig to property or zig to property, and then provide a struct, and it will turn it into property struct recursively. So that's one thing. That we could do, and then have these as zig structs or zig types instead of these things here. But there is a, I mean, I kind of like this as well, because it forces you to use the actual types that are available instead of using arbitrary zig types as well. But anyway, now we can put locks in here. That will be turned into a proper property type. And then now we can go over here, and you're complaining because it's not the same. It's it's properties and not locks. So what we do then is we say to, and then what we want is boundary locks, which should work now because they have the same field names. And there we go. Okay. Now yeah, so now what I want to do is I want to compile this and try to run this now here. Okay, I'm gonna run it. I'm gonna exit. I'm gonna check the things here, cameras. So now we get this thing, and we can see that the rectangle seems to be defined properly here. Cool. So let's go in here again, please. And it seems to be locked. Bottom left, top. Now it should be unlocked at the right. Okay. So the scale is 35 by 17. I think since that's... Okay, I know what's going on. The scale here is 35 by 17. The problem is that the original size of this camera settings is like a tile size. It's not like 1 by 1 pixel. So we actually need to multiply this by the tile size, or the size of the camera settings. So that is the issue, I believe. Okay, yeah, because I noticed the number of the rect was pretty small, and so the scale could essentially just be times 16, I think, which is that is the tile size. Do we have the tile size? No. I mean, it really is like a property of the camera settings. So actually, it's the types. Wait. Entity type. Well, it's custom. I see. I need the entity type. Get entity. Do we even have this? Because I know. So what I'm after really is like the entity type struct, like, because here we have these things that we need to get. So technically I could get this information. It's just that I don't really have that infrastructure right now. I'm just gonna do this here. Fix this hard coded size. I'm gonna name it camera settings size. All right. Okay. Okay, so now it should be scaled up. So we should essentially be able to detect that now. We could add like a debug kind of rectangle or something around the boundary as well. Okay, so interesting. It actually doesn't lock anything now. Why is that? Okay, but the rectangle looks correct now, I guess. Okay, so so the locks all became like true. Yeah, they should all be true, yes. Okay. You know what I was thinking about is like, you cannot define, I don't think you can define a function that has the return type depend on the result location. That would be kind of cool if you could define a function, because what that would give you is, I mean, it's kind of like having a parameter like this, but it's like implicitly the result location type. So instead of calling to, like you could like omit this, and it would depend on the result location instead of you having to explicitly tell what it should go into. That could be kind of cool. I wonder if that is on the to-do list for Zig. Because also what you can do in Zig is you can kind of do this, you can have this converting function that takes any type and then turns it into any other type, like into or something. Like that's very rusty, but like that. So you just call this, you just call it like this, instead of in Rust you would call it like this, I guess. You could call it like this, and then because you have to do it like this because you define this function, and it will check if the type that you put in, or if the values type that you put in has the to function or into or whatever. And then you don't actually have to put the conversion type in here because it would know what you want to convert it into. I guess it depends on how often you come across that that scenario, I guess. But it will be kind of cool. Okay. So what I'm gonna do is I'm gonna grab out the camera boundary here from the entity, and then I'm gonna log out the whole thing so we can see what it is. We could use JSON format. Now we'll simply enter and then exit, go in here and look for camera boundary. Alright, so here's the thing. Okay, so we can see that locked seems to be correct. Like right is false, top is true, left is true, bottom is true. So that seems to be correct. Enabled is true as well. Huh. Okay, so why... Okay, you didn't see that because I forgot to... But here you can see that locked, right is false, but top is true, left is true, bottom is true. So that does reflect the state of the settings that we set from the editor. So that is correct. But for some reason, the camera update function does not actually agree to that. So let's delete that. Excuse me. And then we'll go to camera here. So we should get something here, because that's what we get. Unless we get this, where the locked is all false, which is not. They are all true, so that is correct. So we should get in here to get this boundary. I guess I could write this out every frame. Or every second or something. No, not here. It's over here. The boundary here, yeah. So if boundary is locked right, then we do that. Right, so it's like these are all... It's not like right will shortcut everything else. Right? They are all like separate operations here. So setting right to false will simply not do this, but it will do the other things because they are true. I'm gonna do this as okay, print boundary. So it's gonna print this every second. So we don't get spammed. All right, that should be enough. Okay, here we go. We got some stuff there, and you can see that the locked stuff should. I mean, yeah, that looks correct. So this is weird. What the hell? Am I missing something here? I mean, obviously. Oh, wait. The boundaries rectangle has changed. Now, is this correct still? Okay, so we have a reference here. We have negative 280, 136. So they are the same. It's like 280, 136 at each positive and negative stuff. So what we're gonna do is we're gonna say, okay, well, let's say you actually return this, or let's just get the boundaries equal to the default, which gives us the level size. So let's see how big is that, and that will give us the size of that. Because the size could be wrong. Could be too large. So it's compiled. I will start up. I will wait a couple seconds. Exit. Go back. Look at this boundary. Okay, we can see that this is 120, 46. What the hell? 280? I mean, that doesn't even... 136? That doesn't even divide. Right? Wait, no, it does. It does. It does. It divides to 4. Ah. 4 is the magic number. 4 is like the scaling of something. We're scaling by 4. But this seems that we need to divide by 4. I just don't understand why. Okay, fine. I mean, okay, it might just be that we need to... We just needed to multiply by 4 and not 16. Okay, sure. Let's go camera size is 4 instead. Oops, and we need to get rid of this. Alright, I need to go here soon. I need to eat something and take a rest because I'm starting to feel the fatigue here. Alright, because I'm a little bit under the weather. But this is actually very fun here. Okay, cool. Because it seems to actually work. Like, that helps. But we'll see. We'll see. Let's... Because I would like to... if we get this working properly, I want to test the T layout thing as well. To see. Because that's where we could see the actual, like, edge case issues and stuff like that. Alright, so... Where do we go? We've compiled it. Right, so we go back here and test. Okay. Looking good. Oh, man. Wait, did I recompile? Yeah, that's the default. Is it because the boundary is different? Wait, is the boundary like differently calculated? The camera position might... Oh, because the camera is scaled. Oh, okay. Okay. So the boundary size should still be 16 here, but... The camera actually needs the boundary to be divided here. Divided, yeah. You know what? You know what? We can do this. I just realized something here. We can just abstract right, because it's mathematical. If right is locked, we return right times actually we need to divide divisor. All right. Top. No, wait. I forgot. So if it's not locked, we simply return Math infinite f32, because then, you know, it's gonna be infinite. Yeah, makes sense. Top is negative, so this would be negative infinite. I think you can just do that. I think. I mean, you might not be able to. Is there a way to kind of negate infinity safely? Okay, I guess you can do this. Because it's like sometimes, it's, you know, if for example, if you have a U or an I 8, it can go to plus. It's like there's like differing by 1, where you can go plus 128 or 7 or whatever it is, and then negative 128 or something like that. I don't remember. So that's why I was thinking like maybe it's but this is like floating, so I guess floating point numbers you can always negate if they're like, yeah, okay. Anyway, this would be top over the visor. Yeah, left is also negative. Oops. And then bottom is also, no, it's positive. Yeah. There we go. So now we have this abstracted way to get these boundaries. So cool. So the rectangle is actually like world size, or like world coordinates, and then but this is now converted into camera coordinates. Now, of course, the divisor actually it relies on the zoom actually. So you know what? We actually need to pass in the zoom here. So if you zoom in by 4, we need to divide by 4. I think that's what we are actually doing. Yeah, I think so. Oh, it's 6? Wait. No, 3 by... Wait. 6? Okay, so it might be different. I don't know, but I'm pretty sure 16 is the correct number for the thing. We'll see, we'll see. We'll see. Pretty sure this is what you're supposed to do here, yeah. Alright, and then when we are doing this here, we still get the boundary as per usual. And you can see here we're actually dividing by zoom here directly. Oh, but this is the screen. So this means we don't do this scaling here. Okay, wait, why are we doing this? Is it because, okay, it's because the camera is probably correct. This is not used now, fine. Alright. I don't really need to see this again. There we go. So actually now, instead of using rect right, we have to use these ones. And then camera zoom. All right. I mean, I guess we're kind of converting, like when we get the target, we're converting to camera coordinates. Or like screen coordinates, or... No, we just get the center plus offset. Huh. Relative target camera position. Oh wait, no, because... Okay, so the camera position is in world coordinates then. No, now I confused myself. What was the problem actually? It's like the size of the boundary should be 16. So I guess the target here doesn't care about zoom. So we don't actually need to divide by zoom here. I don't think so. I don't know what I was thinking that. I don't think we need this. That is to get... That would be to get to world coordinates from... Yeah. I think. Alright. Okay. Yeah, because I was thinking like if we zoom out, but that shouldn't actually like matter for anything here. Yeah. Okay. So now let's see, the camera setting size is 16, so that's correct. The default level, the default boundary is like, but now this should be times, I think. Wait. No, I think this is correct. Man, I'm so confused right now. Okay, let's just test this to see where we are. Whoops. No. Okay, now we're here. Now the boundary is too large now. Okay. And of course we don't have the debug messages anymore because I removed them. It's too large. I don't understand that. Oh, wait. We need to do this for the boundary as well. Right. Or do we? Yes. This is the thing. Okay. All right. So we get the boundary. So boundary is equal to that, and then we simply do this, and then we return boundary. And we can get the screen as well. Okay. Wait. Hello, explain the diff game with the type star game and self with the type star game when making a function parameter. What does that mean? I mean, it doesn't actually, there's no difference really. Like it's gonna compile to the same thing. It's just a convention to, if you have a member function, to call the first. Okay. So here's the game struct. I mean, it might be a bad example because there's so much stuff in here. But essentially, if you have a function on a struct and the first parameter is the same type as the struct you're in, then this is called a member function, which means that you can say game, if you have a value of type game, you can say game.deinitialize. And this is essentially the syntactic sugar for calling game, you know, the type deinitialize. This is the same function, and then providing that as the first parameter. So these two are equivalent. And it's just a convention that, like, I kind of, you know, didn't use the convention here. So this should really be called self here if you want to follow the convention fully here. But, you know, the name doesn't actually matter. But what matters is if it's in the first position, if it's a parameter. So the parameter, so if you had something like this, that this would not be a member function. And you can't call, you see that it changed here, you can't call the initialize on here. Now the initialize is actually not available on the value here. So it has to be the first parameter. And now it's a function again here. But it's essentially just syntactic sugar for calling this function with game as the first argument, like this. And syntactic sugar, if you don't know what that means, it just means that it's just a, you can write this is equivalent to this. It's like the compiler is gonna rewrite this into this. Hope that makes sense. Otherwise, feel free to ask any questions you have. I'm happy to answer anything you want to know about Zig or programming in general. correct, but I want to know why you use self and game. So you would use self. I mean, as I said, the name does not matter. Like the compiler doesn't care if you call it self or game. That's not what. It's just a convention. Like you can have, So the convention is that you would use self. That is the convention. If you have a member function, the value that refers to the struct is called self. That is the convention. I use game here because I didn't follow the convention. That's the simple reason. Like I don't know why. I can't tell you why. It's just that I decided to not follow the convention at this point. It's not right or wrong, but it's like it can be confusing if you're used to the convention, but it's only a convention. The compiler does not care about conventions. So it's going to be compiled to the same thing, whether this is called name, self, or game, it's going to be compiled into the same thing regardless. Yeah. And this is just me being silly, not using the convention. Yeah, good question, because sometimes you get confused about things that well, I get confused about those kinds of things. It's like if I don't have the context, sometimes if you don't have the context, it's very hard to like. I want to see the full picture as well. So a good question there. Okay, what were we doing here? So do we divide by so like because that was 6 and not 4, so maybe that is different. I am confused. I'm very confused right now. So the boundary was divided by 4, but the level boundary is actually not really used by any collision detection or anything like that. Yeah, it's only used here for the camera. So this calculation might just be wrong here. Like the level size is determined. Okay. I don't recommend doing this either, having a global variable basically and then a function that refers to this global variable depending on whatever it is at the current moment, because as you can see already it's kind of hard to see where is this actually changed. I mean, it can be changed anywhere, from anywhere. So I don't recommend this pattern. I used it because it was convenient at the time, and I was like very early in my Zig days. But yeah, I think this is where we actually set it. Init level, right? So we get a level from the thing, and we actually have the size here. We take this as grid size times the tile size. That's simply the pixel size in world coordinates. Yep. And then this is used to get the level boundary, which, so that, okay. So then I don't really understand why dividing that by 4 is wrong. So then this should be 4 and not 16, which is weird because it should be times 16. I don't understand why that is different from the level size. Really? Because the tiles are 16 by 16 pixels. Like we had this old scaling system where we scaled everything by 4, but I removed that, and now we zoom in with the camera instead. So I don't think that is what's causing this. I don't really understand why we only scale this by 4. Because even this was like 35 times 17, which is the default like tile size of the tile map. So 34 by 17 tiles. And then the tile size is 16, so that will be 16 times 35 and 17, which gives us whatever we got there, like 280. But then apparently that is incorrect. But I guess, what if we add, we just keep it the same. We have this size half correction. I mean, maybe that's the issue, like we add size half. Like, I'm not sure why we're doing that. Because it's a camera and it needs the screen to be... No, I don't really understand this. And why is the level boundaries different? Why is this different? Because this should be the same thing. This should be 35 by 17 and this should be 16 by 16. Yes. I don't understand what the issue is. Very strange indeed. And even with... Oh wait, it's removing size half. I just realized that. It's not expanding by size half, it's removing size half. Oh. That's why it's different. Okay. Okay, so actually this should be 16. Okay, yeah. Okay, now everything makes sense. Now everything makes sense. Because that is the size, sort of the camera viewport. Okay, yeah. And we have to do the same correction over here. Okay, yes. Good. So, also we probably... Do we want to do this? If the width is less than 0... I guess. Sure. We could make this into a function. So boundary viewport adjustment. Is it C screen? No. No, it's ZGE screen. Alright. So we'll do boundary viewport adjustment. Let's just get const. Alright, and same thing up here. All right. Zig doesn't split data from its behavior for a type compared to, say, Rust, which separates type from behavior. I mean, you don't have to have member functions. You can define functions that work on like structs, like that. They don't have to be member functions. And you can also define, you know, generic functions that take any type. So it's like I mean, for example, here I'm defining a function that works on that's not bound to any struct. Well, that's technically not correct since we're in a file. All files are structs. But you know, essentially this is like a function that isn't really part of a. It's not a member function. Zig is talking about traits or interfaces. Yeah, I mean, Zig doesn't really have traits. But what you can do is you can say you can have a function. You can do it more like, kind of like, you know, if you would compare something, this is more like how Haskell does it, where you have a function that's defined outside of a trait or whatever. Well, Haskell actually has like type classes, so they are kind of like more powerful traits. But let's say you have this function into, and you have, let's say you have a, so we actually need to have a type that we want to turn this thing into, because you can't use the result location there, but you have to provide a type. But then you could take, and then you could take like value, which is any type, and then you turn this into a t, and then let's say you just call, you can get the type of the value, and you can say to t, and now what this does is essentially says that whatever you put into here, so let's say we say x equals into u32 and then 5.5 or something like that. Now this doesn't really work, because this is one instance where it doesn't work, because this type is like a primitive type, so it doesn't, you cannot actually define functions on it. But if you have like a struct which is like my float or whatever, value is a float, and then now if we say, you know, my float where value is 5.5, it's gonna complain because my float doesn't have it. Okay, yeah, my float has no member named 2, but you can fix it by just implementing it. So we're essentially implementing this kind of interface, sort of, and so we implement this function to itself my float, and then we need a comtime resulting type, and now we have to implement this function. So, but essentially, let's say t is u32, return int from float self.value. If it's something else, return. Then we get a compiler error saying cannot convert my float into type name t. Okay. Wait. Right, we need to provide the actual actual value as well. All right. So now, and then compile log. X gives us that thing. No. Well, we actually have to compile to see the thing, but that essentially that works, and then where is that thing? No. Okay, it might not work because we got some other errors. But essentially, this is what you could do. Can you call instance.method if the method is out of scope? So member functions can only be defined on the struct itself. You cannot add like more member functions outside of the struct. So this struct here, for example, 2 is the only member function right now. If you add another function up here, let's say my float 2 or whatever, and it has, let's just have the same function here. Like, you can define this function. There we go. You can define this function perfectly well, and essentially it's the exact same function here. The only difference is this function is kind of, it's like conveniently marked as a member function and is part of the struct. This is not part of the struct. So it's not a member function. So you cannot say, for example, if you have a thing that is like my float is a my float, you cannot call my float 2 like this. So this doesn't work, because this is defined outside of the struct. If you put it inside of the struct, now all of a sudden it's there. So you can't like add more member functions after the struct is done. Which is, I don't know, it would be cool kind of if you could. I'm not sure if they want to go that direction. It's kind of like the extension methods in C#. I don't know. I'm trusting that they have something cool cooked up for us, maybe, you know, in the future. Yeah. But you can call, you know, .2 here to call a member function, which exists here, which 2 there. So yeah, so there's no traits, but you can do this where you have a function that you call that is not tied to like an interface or anything, but there are like what we call interfaces as well. So there are like types that you can use kind of like interfaces that have different implementations depending on which instance you're using. So there are kind of like interface types, but they are not really like traits. They function more like I'm not sure if I dare to say decorators, but kind of like decorate. Like you could have a decorated type that implements different interfaces. And for example, if you go to memory allocator. This is an example of that. But this is like the old way of doing it. But this is an example of and this is kind of weird because the file itself is the struct. So here's like top level fields which are part of the allocator struct, which you can see here. Allocator is equal to this, and this refers to the current struct that we're in, which is the file. So allocator has a pointer to the implementation data, and then the vtable, which is the implementation functions for that is supposed to be paired up, so the data is, you know, different implementations has different types of data. So pointer refers to the data, vtable is the vtable. So that is one way of creating an interface in Zig. What are the ways you can split the code for my float type if it gets too big? Let's see. If I can split the code. I mean, yeah, that's not really possible. I mean, before you could use something called using namespace, where you could essentially import functions from another struct, essentially like inject sort of functions into, or declarations into another struct. Now you cannot really do that. I mean, what you could do, potentially, you could do something like this. Let's say you have this function defined outside here, and then you could just create an alias. I'm gonna call this my float2 because of naming collisions here. You can create this alias here, and that's perfectly fine. I'm not sure if this corresponds to a member function though. Actually, I don't know. Yeah, you can. Okay, so this actually counts as a member function. I actually didn't know that. That's pretty cool. Yeah. And just to show you then that if you try to use some other type, you will get this compiler error. Kind of convert my float into usize. Yeah. And you can create a whole like convert, you know, this into like a very, you know, sophisticated thing where you can maybe automatically convert floats to ints, ints to floats, or I mean, there's built-in functions for that and stuff. But yeah, this, I guess this would be one way of kind of moving the functions out into other implementation files. But you cannot then, all declarations and fields has to be defined inside this struct. So yeah, so you would simply have to have it in there. I mean, just look at my game struct here. The game struct is like, I mean, it's like line 20. It's not really huge. It's like 100 but there, since there's not a lot of things in here, there's mostly like wrapping functions. That is, I mean, okay. This is how you could do it. This is what I did. Actually, this is an example. I'm not sure if this is a really cool good pattern or whatever, but I simply just define another function somewhere else that I call with game. And this is not technically a member function. It's just a function defined somewhere else that takes game as a argument, and then we have the implementation here. And then these are simply wrappers into those functions. So this would probably get like optimized away. So this, I guess this would be one way of doing it. Yeah, but the fields are, so the fields, what you could do with the fields, I guess, what you could do is you could group them Like for example, I have a bunch of arenas here. I could group those into like allocators or something, a struct called allocators, and then that struct could be defined in another file. I could group, yeah, you know, just group a whole bunch of things here. Maybe these things are like some kind of config, you know, yeah. So that's what you could do. Like instead of having all the fields out here, this could be grouped into a player struct or whatever, and so on. Something like that. But in the end, you can't, like, if you have a struct defined like this, you have to, like, every field that's inside and every function inside has to be defined in here. But I haven't really, I mean, yeah, this is actually one of the solutions to that issue here. Yeah. Okay. Thank you for asking questions. It's always nice to discuss a little bit. Okay. So where were we here? Boundary. Oh yeah, because that is okay. So camera boundary. I mean, okay. Actually, you know what? Let's change this to work with a rectangle instead. Actually, yeah, that makes sense. And then you need to be rect. There you go. And you are correct. Okay, cool. There we go. I think that should be good. Yeah, that's correct. Okay, confusion averted, actually. I think. Let's see if this works now. Oh my God. Of course it doesn't work. Of course it doesn't work. Wait. It works to the right. So right is unlocked. So that does work. Okay, so the locking thing works. It's just the size is wrong, probably. So now it's too small. Oh, I see. We need to divide by zoom here. Yeah. Because this, okay. Because the zoom matters on where you're, okay. Yeah. So it was kind of calculating based on the fact that we were zoomed all the way out. So I'm just gonna add zoom here. I guess game camera zoom. Same thing here. Okay, so I think we just divide by zoom here. Yeah. So that's why that was happening here. Cool. Okay, now I have high hopes. Excuse me. Oh man. Oh shit, time flies. Okay, I really have to go. Man, I just want this to work now so I can actually test this out. Okay, there we go. Hey. And the right is unlocked. Okay, cool. So the basic functionality works. Awesome. I'm gonna try just a basic test here to see. Okay, so if we're on this side, we get right unlocked. Okay. Do you use LazyVim or do you have your own custom setup? I have my own custom setup. I spent like I don't know, a week finally taking the time to set up my own custom stuff. Okay, so this thing I want to have left side locked, but then up should be unlocked. Okay. So now the left side is locked, so it's like there's a thing here, but then once I go there, it doesn't work. Strange. And then up should be unlocked, right? If I go left over here now, it does do this, but there's it's like on the left side. Is it because the infinite thing? Why is this happening? Did you make this level editor yourself or is it off the shelf? Yes, I made it myself also in Zig. It's like with this game, or actually the game before. No, was it with this game or the game before? No, it was with this game. Yeah, specifically with this game, I made the editor as well, because it's like I wanted. So it started out. It's kind of funny because it started out as just. So I really like programming. So I really like to, instead of using a tool like Unity or whatever to make my game, I really wanted to have like full control of everything. So you know that's what I want to do. So I made a game just using programming, but the problem is that when you want to do something like create a level or something like that, then it's gonna be pretty tough to do it like in code only. And so that's when I came up with the idea that, okay, well, what if I made a tool that is like specifically for this type of development where you wanna make the game fully in just coding, but then using a tool to make some of the assets, like the levels and the. So what I have is like levels, entity types, animations, and a couple of other things. So that, and they are basically stored as JSON files that we just read in, or that I just read in from my game engine, and it like spawns out, reads in the data like that and spawns the levels from that. So that's been really cool actually, to have this, to have the editor as well, like working, and being able to use that. But why is this not working, man? Okay, this was the thing that I was worried about, that this just doesn't work. I'm pretty sure we could make it work though. The right is open. Everything else is locked. Why would this be like stuck like that? So essentially we're looking at something like this. Does it go up? Yeah, it does go up it just doesn't go to the left. I mean, I suspect it has to do with this part and then this part over here. You know what? I forgot something. So the rectangle, yeah, actually, okay, my mind is thinking about a lot of different things at the same time now. The rectangle, it's like we have two different rectangles. We have like the size of the boundary, and then we also have the option if it's like open or not, which makes that size like infinite in one of the directions, or that direction where it's open. So if it's open to the right, it makes the right infinitely far away, but we still want to keep the original size available to us as well. But when we do this boundary viewport adjustment, so contains point should be using the original rect there. Yes. And then this is using, this is like the camera stuff. Man, what was I thinking here? Because it's open to the right. So should this use the infinite ones? I think so, maybe. So maybe we should use this. Okay, actually, let's make this what am I okay, trying to do here? Actually, I think we could keep this as it is, but what we could do here is we're changing the rectangle. Actually, it's not gonna be that. So what I'm thinking that we're gonna do is we're gonna go over here, we're gonna get like rect with unlocked. No. Hello, Superbat. Welcome. I just joined the stream. What is Metroidvania and what is kottefolket? So, okay, good question. I mean, Metroidvania is kind of like this game genre, where you basically, I would say, it has a lot of exploration. You find like upgrades to be able to access new areas. Yeah, there's usually like platforming involved because there's like exploration and you know, finding secrets, Couple of games that have this genre, like Super Metroid, I would say counts, like basically all Metroid games. Castlevania Symphony of the Night. Basically every newer Castlevania game, I guess. Hollow Knight, Silk Song. Yeah, there's a lot of Metroidvania games. I mean, yeah, I would say it's like a platformer where you find upgrades to access new areas, stuff like that. It's a kind of a broad thing, but it's like when you take a bunch of different mechanics and put them together, it essentially becomes a Metroidvania. Or you could describe it as a Metroidvania, I would say. Kottefolket is my game, so that's the name of the game. And it's Swedish, and I'm not sure if that's actually going to be the title, because it's Swedish. I'm not sure, but you know, everything is up for debate. But it essentially means the people of the pine cones. I mean, kotte means pine cone. It can also mean, what the hell are those called? Spruce? Spruce cones? Whatever it's called. Some argue Dark Souls is a Metroidvania. Right. Yeah. You could probably name a lot of games that are not like, that have that tag. You could probably set Metroidvania on them, or argue that they are also Metroidvanias. I mean, I would argue that Symphony of the Night was not the first Metroidvania, because you have games like Super Metroid, and that essentially embodies everything that a Metroidvania does as well. Like the Metroid games, I would say, are like the, I mean, even games like Zelda, because that's also a game where you explore and you find upgrades to access new areas. It's not really much platforming, though, I guess. I guess Metroidvania has like this inherent idea of platforming, I think. Or at least most games that call themselves Metroidvania. Anyway. I want this rect that is modified with infinities. I don't know what to call this, so I'm just gonna call it rect with infinities. It's such a bad name. It's a really bad name, but whatever. I can see Zelda being early Metroidvania, yeah. Especially Zelda 2, because that is closer as well to, you know, it's a 2D platformer, side-scroller platformer. Whereas Super Mario would not be a Metroidvania, because every level is like a, you know, like linearity doesn't have anything to do with it, but you can complete each level without having any upgrades, essentially. What's with the negative standard math inf? What's going on here? Okay. So this is essentially a representation of, well, essentially this will turn into a value that is type F32, that is kind of thought of as infinite. I think really what's happening is just the max value of an F32, like the maximum value that the F32 can ever be, which essentially becomes the same as infinite, sort of. Almost, because any number you compare it to will be less, except for infinite itself. And if you like, because it's capped out, so I'm not sure. Like if you times something or add something to it, I guess it won't change the value. I guess unless you have it, like, because even if you have an infinite number or infinite, it should still be infinite, right? I'm not sure if maybe Zig has special operations or like it has like special checks for if a floating number is infinite or not. I actually don't know. Because if you just take it by its value, like it's I'm not sure if that's actually how it works though. So it might be that that Zig actually makes it into whatever number represents infinite, and then any operation on that number will be different than a normal operation. I'm not sure, or if it's built into the architecture. I actually don't know. But the idea is that it's just infinite. It's supposed to be used as an infinite number, and then this is the, you know, just the type of the variable. And if you put negative, it's negative infinity. So and I'm using it because my camera boundary, if it's unlocked in a certain direction, I'm gonna treat it as being infinitely far away. So that is the reason why I have it here. And so this one would essentially be in it, wait, from center. Size is well, actually, you know what? It's actually gonna be like this. So top left is gonna be so this is X, so this is left, and then top, and then bottom right is right, and then is okay. Right. There we go. Okay, and once we have that, we can now say racked with infinities. I have such a bad name for it, but whatever. This is going to be the boundary rect. All right. Also, we can say that this is I don't know the programming language Zig yet. With what other programming languages could Zig's feeling be compared? I would say probably it's like a modern modern take on C. If you want to compare it to something, like it has a very basic structure. Like it doesn't have classes or I mean, it has interfaces, but it's not really like a language construct. It's more like the thing that you can kind of construct interfaces from the tools of the language. So I would say it's like, because their structs are the basic building block, I would say. sort of like yeah. So, and that's the same as C, you know, and Rust. It has similarities with Rust, like syntactically, as Minister of Defense says. But I wouldn't say, yeah. But Rust has like other features that doesn't exist here, like traits and stuff like that. And it is low level, yes. It is. It has manual memory management. So you have to allocate and free memory yourself, just like C or C++ or Rust. Go has garbage collection, but it's it's also kind of, you know, the same idea with the basicness, where it has like basic structure and stuff like that, but it has garbage collection, so it's not like as low level. So I mean, yeah, as far as I know, like I would compare it most with C. It also has very C friendly interfacing, where you can import C libraries directly into Zig, essentially, and use, like, you get like auto completion and automatic conversion of types and compilation. So it's like almost as having like C as an extension of the language itself as well. And you can also define C-like functions as well. You can define functions in Zig that you can call from C as well. So I would say it's very close to C, but it has a lot of modern takes on different things, which makes it more convenient, I would say, to use. Even though I haven't really used C that much, but you know. Let's see. Yes. So let's put you here. Now, the thing here is kind of weird. I'm not really sure how to think about this. Like, this was never a problem before. It feels like the scrolling works, but it's like weirdly offset. Oh, maybe it's because we set it to 0 here. We shouldn't set it to 0 here. Because, yeah, this is the issue. Yeah. This is the issue here. We need to set it to the center. Okay, let's save the center point before. And if this happens, we need to set it to the center of X. Because before, the center was always 0 when it was the level boundary, but now it's different. Okay, I think that was the issue. I think so. So I think we don't really need this part. No. Yeah, this was just weird by me. Let's just forget that ever happened. Yeah. Alright. Cool. Hey, cool guy. What's up? And it has its own C compile too. Yeah, I think it's using... Well, actually, yeah, I think they rewrote... Well, they were using LVM and stuff. I'm not sure what they're using for C. I'm not sure if they have their own C compiler or if they wrote their own C compiler or if they're using something else. I don't know actually. And I know they rewrote like the compiler backend for Zig though, from LLVM to something else, and in that they have to kind of, you know, deal with C as well somehow. Okay, let's see if this works now. There we go. Okay, well, it doesn't work perfectly. Like up and down works good, but left and right is weird. Why does it go over there? Why? Man, it feels like we're so close to get this working here. Should I learn Go or Rust as modern low-level language in terms of job? As I always say, it depends on your region, like where you live. Like, go out and look at what are, like, how many jobs. Go and search for jobs with Go and jobs with Rust, and then see. You know, it depends. If you can work remote, great. I mean, otherwise I would see like, okay, how many jobs of Go do you have near you? How many jobs of Rust do you have near you? And then you go with that. Yeah, I suspect Go is more popular. Yeah, because it's been around for a long time. And Rust is growing, yeah. Especially with all the news. Ban going over to Rust. Alright. And especially with AI, because then all the leadership people will see that, oh, AI is good with Rust. Okay, so then, you know, maybe that's feasible. Let's jump over to that shit. And Rust is really good. Alright. Why is this happening now? Is the question. Skips the center is like off. Should we use the new center instead? I mean, what if we just do this? I know Mern already. I want to learn modern low-level language. I can do both the stuff. So Mern would be... Wait, M... Is that Mongo? Wait, what does E stand for? React Node? Express? I do nothing about what goes in making a game. Wait, I know nothing about what goes in making a game. Example, what is stopping you from making an awesome dude? Here looks like a human figure. I mean, what's stopping me is like artistic talent, I guess. Yeah, I know what a express is. I was just thinking because express and node is kind of like, well, I guess nowadays you have bun, but you know, express kind of implies that you have node. And no, that wait, did I compile? But yeah, making a game, I mean, it turns out it's essentially just a lot of hard work. Especially if you're by yourself. Okay, yeah, I did this. That did not work either. That had the same issue. But it did change things. I mean, this whole thing could be wrong, like, because I never actually got here. Yeah, it's like the rectangle is too small for the camera. But it at the same time, it's not, right? It's not actually too small. Because we go over here, and the camera is smaller than the boundary. Oh, but then we go over here and... Right, because the rectangle goes kind of like here and then stops over here. So actually this makes sense. Now we're... Okay. At the center point. So it should be something like this. Yeah. I see. But if we have something open to the right, then the left side... So then the center point is kind of infinite. It should be like infinitely far away or something. So that's why we need the infiniteness. Right. Okay, so we do need the infiniteness here. Okay. So that wasn't a huge waste of time. So let's do rect with infinities. And then that is the thing we change. And then here we want to kind of restore depending on which ones are not infinite. No, we just set it, right? No, because we need... No. Yeah, no. We're not actually... No, yeah. That's true. We can just set this to rect with infinities now. Yeah, that doesn't actually change the original camera boundary. Yeah. So there we go. Okay. Do you plan to hire an artist, or are you going to try it all yourself? I'm going to how I see this right now, what I'm making is kind of the prototype graphics to kind of get a feel for how it's supposed to be. Especially, I mean, I'm really bad at characters, like especially the main character. I don't know. I kind of want to have the same feel of the game, like the 8-bit feel. There we go. Okay, cool. And of course, you know, it's not, you know, a real camera setting wouldn't really be like this. But also, I probably want to have a transition as well. Like when you go from one mode to the other, we probably want to have a transitional thing as well. Like from here, for example, it goes like up directly. We should have like kind of maybe like a pan or something. Alright, code guy. Calm down. What tools does an artist use to make this do... what tools does an artist use to make this to a real looking human in the game? Okay, so I won't change like the resolution. I think the resolution is good. I mean, I don't know. It depends. Like if I hire an artist and they come and say like I can't work with this resolution, we have to change it, then fine. I mean, if we can redo all the assets in like higher resolution and it still looks okay, then you know we could do that maybe. I don't know. We'll see. It depends. I want the 8-bit feel though. Like that's important to me. But the design could change, like, you know, for all I care, the design of the main character could change a lot. Like you could redesign the whole main character, because I'm not really happy. It's just to have something to show on screen, really. But what tool, like the tool, I mean, I can't say what tool a real artist would use. I use GIMP for the graphics in this game. If you want to make like a pixel art game, then there's tools like what the hell was that called? Yeah, I mean, you could just Google it, but there was a specific one that I was thinking about, like pixel art tools. Asus or Sprite. I'm not sure how to, you know, how to pronounce it, but this site has a program that is used by many people, as far as I know. I just use GIMP, but which is free as well. So, you know, but this has more. This is more like specific to pixel art and has a lot of tools that is specific to that. And yeah, you can do animation. Yeah, exactly. As sprites, yes. Exactly. That's what it's called. Hello, Vincent, by the way. Alright. Now okay, so we got the basic thing working actually now. So the problem is, let's go ahead and actually test this now in the T section. Okay, so we'll add camera settings and we'll add it over here. So this part will have, like, I guess, let's put it like this maybe. So this would have everything locked except for right. All right, save. And then I want to have, let's see, let's have like, I don't know, should it be like this? Maybe, or maybe, I don't know actually. Maybe this should be like, no, because this part should be left and right unlocked, and once you go in here, well, let's just try it out. I mean, yeah. So this should have like left and right unlocked and top as well. Okay. And then, whoops. Oh, that was the wrong thing. Here we go. And then you are, it's good to get the boundaries correct when you're at the edge, because that determines what you can see as well. So this one should have left unlocked. Okay. And now we essentially have the rest of the thing over here. Except it actually needs to go like this. And actually even further, because I see the background there. Yeah, there we go. Okay, and then you will have the bottom unlocked. There we go. Hello, hello. Okay, there we go. And we can hide them so we don't need to see them all the time. There we go. Okay, so let's try this out now. So down here is like locked and then open to the right, and to the left it's locked, to the top is locked. And it should be like, you can see we can't go further up here, but as soon as we enter this part, we go into this new camera. But as you can see, it's kind of jank. It's, I mean, it's kind of jarring. And that actually transitioned pretty smoothly. But it actually works pretty well, more like even better than I thought. And then once you, whoa. Jump up here, we go into this locked, horizontally locked. Awesome. Yeah, we don't have any background anymore. Cool. So it works actually really well. The only thing is the transition. Yeah, as you can see. I think I want to have like a... how do we actually determine that? But that's gonna be it for this time. Wow, that was abrupt. I just remembered I really need to actually eat something and stuff. But yeah. Okay, I just need to write this down here. So the camera boundary stuff works really well. What I'm gonna do is like update boundary here. To do fix implement smooth transition when switching boundaries. Yeah, so we need to figure out when does it happen. How do we fix it? Yeah. So, yeah, really cool. I'm really glad to get to this part because this has been a long time coming and I've been debating how to implement this. But this really seems like a good candidate here, and it wasn't really too bad, too hard to do it. Like, we still need to worry about figure out the dynamic boundaries, but I don't think that will be a huge deal. As long as we have this basic framework in place, we can simply like deactivate, activate boundaries, which will automatically work here. So yeah, but yeah, let's see. Arset Sammy, I feel bad given I know nothing about game making, but I keep watching you and will keep quiet. Someone can explain while you co-play. Oh yeah, no problem. Like, you can ask any question. I might have missed something there, but I mean, I gave you an answer to your question, I think. Like, check out the link that I posted there if you wanna check out, or GIMP is also, you know, a free tool that you can use to make pixel art or any art for that matter. If you're interested in that. But yeah, don't feel like you can't ask questions. Yeah. But anyway, thanks for watching and hope you have a nice day, and I'll see you later.